We're doing geometry again today?
Yep.
Okay. That's right. You don't have finals this year, do you? You don't have to worry about that. Well, next year.
Next year, though.
Next year you will, for sure.
Woo, yay. Except not.
Yeah, your sister can probably tell you all about that, about finals. She's probably in the midst of studying for all of them.
Yeah, that's what she's told me.
Mm-hmm. All right. And number 3.
Okay. So,
this is one you may not have enough geometry to know how to do this.
360 divided by 8, that should equal 45 degrees?
Very good. Is that what 360 divided by 8 is? Yeah, 45 degrees.
Yeah.
In other words, if I had a quarter of a circle, that would be a 90-degree angle, right?
Yeah.
And this is a quarter of the area of the entire circle, and it's also, this arc length from there to there is 1/4 of the circumference. So that ratio is always true. In other words, if you take that angle, in this case x, and divide it by 360, that will be the same percentage as 1 divided by 8. So x is going to equal 360 divided by 8.
Yeah.
Hold on, let me see if I can get this displayed properly. All right.
Would it be
Shaded region problems are always what?
subtraction?
Okay. So let's start with what?
Subtracting 6 from 4?
Well, let's start with the area of the big semicircle minus the area of the small semicircle. That's going to be that shaded region.
Okay.
Okay. So now let's talk about the area of the big semicircle. What is that?
9 pi.
That would be the area of the entire circle.
Oh, sorry. 9 pi over 2.
Okay, so 9 pi over 2 minus the area of the smaller one. What's the area of the smaller semicircle?
That would be 4 pi. Oh, well, you can just make that 2 pi.
You got it. Okay, so now that gives us the shaded area. What is that equal to?
Would that be
How do I...
5 pi?
5 pi over 2. In other words, how do you subtract this from this?
You have to make the giant one, so it'd be 2 pi over...
It would be You find a common denominator, so it becomes 9 pi over 2 minus 4 pi over 2. In other words, 4 pi over 2 is the same as 2 pi. And now I have a common denominator of 2, so the answer is 5 pi over 2. However, that is the area of the shaded region, which is not what they wanted. They want the fraction of the large semicircle, the shaded region, divided by the area of the larger semicircle. So what they really want is, there's the area of the shaded region. I'm going to divide it by the area of the larger semicircle. What's this equal to?
Um, 5 pi over 2 is equal to...
Don't do it that way.
4.
Don't do it that way. In other words, use your rules for how you divide by fractions. What do you do when you divide by a fraction? Same as multiplying by the reciprocal, right?
Oh, okay. Yeah.
Well, there's the reciprocal.
So it would just be 5 pi over 9 pi, and you get 5 over 9.
Exactly. In other words, the 2's cancel, the pi's cancel, and you get 5/9. That's the ratio of the shaded area to the bigger semicircle. That's actually a fairly difficult problem. I'm surprised it's under basic. Let's see, I need to go to another page.
So, for number 5.
Yeah, let's see. Number 5 does not have to do with this figure here. Let's draw a circle. And they said a line segment joining 2 points on the circumference of a circle is 1 inch from the center of the circle. So that value is 1. If the circle has a 2-inch radius, what is the length of that line? We'll call that line AB.
All right. I don't know how to solve that.
Okay. I purposefully drew my radius there, but when you're dealing with a circle, all radiuses are the same if it's within the same circle. So if I draw my radius like that, now I can solve this. What angle is this right here?
That's a 90-degree angle.
Right, by definition. When you take a chord of a circle and connect it the shortest possible distance to the center, you have a 90-degree angle. So now, can I figure out that side of that triangle?
Yeah, that should be
root 2. I have a triangle whose that side is 2, and this side is 1. What's this?
Root 2.
Do the Pythagorean Theorem. It's the square. Remember, when you're solving a right triangle, that the answer always begins the square root of. the square root of the hypotenuse squared minus the other side squared, which in this
Oh,
case,
so it should just be 1.
square root of 3. 2 squared is 4, 1 squared is 1,
Oh.
4 minus 1 is 3, so it's the square root of 3. Okay? That's this little short side right here. From that point to that point is square root of 3. So what's the total distance from A to B?
From A to B, it is 2 root 3.
Exactly. It's twice as far. In other words, the principle in geometry that is at play here is that when you have the center intersecting a chord at right angles, which means it's the closest distance, then it always bisects that chord. So if I put a point C on there, AC is always going to be equal to CB. So once I solve this little tiny triangle, then you know what AB is. It's twice whatever this side was. All right.
So,
What are CD and BC equal to?
BC is equal to 8. And then CD is equal to 16.
Since they want the entire area, what's the area of the semicircle AB?
Pi times 16 divided by 2, so 8 pi.
What's the radius? Right? What's the radius of that semicircle?
2.
It's the area.
Oh, yeah. So it would be 2 pi?
Yeah. 2 pi is going to be that area, because the area of the whole circle would be 4 pi, right? So the area of the semicircle is going to be 2 pi. Now let's take this semicircle. What's the radius of BC, or of that semicircle?
Okay. 4, and then that's what equals 4 pi.
Hold on, do it again. Wait. Do it again. If the radius is 4, what's the area of the whole circle?
16 pi.
Okay.
And then you divide it by 2.
Okay.
So 8 pi.
Okay. Do the same thing with CD.
Alright. 1 sec. So it would be 128 pi.
What's the radius of CD?
Oh, sorry.
It's okay.
I solved for 8. So it should be 32 pi.
You got it. Add all those together, you get 42 pi. That's the answer. This kind of demonstrates why radius is the key number for any circle or semicircle, not diameter. One would think that diameter would be just as important, but everything you have to calculate is based on radius. When you do the area, it's based on radius. When you do the circumference, it can be based on radius. So get in the habit of thinking about circles as what their radius is, not what their diameter is.
All right. So O is
Let's see. The area of the circle is 100 pi. Let's start with that information.
so that means the radius has to equal 10. So
Where can I label 10 here?
From 0 to B. Or O
Also
to B.
from 0 to B.
So,
In other words, that's also 10. You're right. 0 to B is also 10. They tell us the next piece of information is that CA has a length of 6. Can you figure out what AO is?
8.
Now can you figure out what AB is?
That would be 2.
You got it. Geometry's a piece of cake. Actually really is. You're doing really well in it, considering you haven't ever had it.
Thanks.
Yeah. Like I said, before you start your class, we'll work on the hard part of geometry, which is proofs. And it's only hard because it's so different for most people. Not that hard.
All right. So
how would I figure out what's the formula for the area of that triangle?
25 equals 1/2 BH.
Our ultimate goal here is to find what?
The area of the circle.
Okay, excuse me, let me back that up. What's the thing we're going to need to find before we find that?
The dimensions of the triangle.
Radius, right?
Oh.
In other words,
yeah.
Radius is the key thing. You can't figure out anything about a circle until you come up with the radius. Well, which is the radius in this formula here?
Would it just be either the base or the height? It would just be the base or the height.
All radiuses are equal in the same circle. So OY is equal to OX, right?
Mm-hmm.
OY is the radius of the circle, but so is OX. So in place of B and H, I can stick an R. That's the base of that triangle. That's the height of that triangle.
All right.
Okay. Now, apply your algebra and solve for R.
25 equals R.
Hold on. What's the first step here?
Oh, well, you could go about multiplying both sides by 2.
So 50 equals R times R, which is what?
Oh, that's R squared. Okay.
Right.
So then you get 5 root 2 equals R.
Well, let's just start with square root of 50. Why? I don't need to worry about simplifying this, because what's the area of a circle equal to, the general formula?
Pi R squared. Oh, yeah.
So all I needed was R squared. So what's the area of the circle?
50 pi.
Exactly. Just for the heck of it, simplify the radius.
That would be 25 root 2.
25 root 2 or 5 root 2?
5 root 2.
Okay. because it's the square root of 25 times the square root of 2. Good. Very good. So I've got to go to another page. Advanced. The fact that we can even be doing the advanced is impressive. I've done this with people before and who are just starting out in geometry, and I don't even present the advanced to them. I start out with basic and intermediate. Leave the advanced.
Okay.
Yeah, well, I don't do the advanced because if they're just learning geometry, I just kind of assume that it probably is too tough. But you're proving me wrong. All right. Increase the diameter by 50%. What happens to the area?
So that means the radius gets increased by, would it be also 50%? Or
yes. No, you're correct. Let's take an example. Let's figure it out. What's this diameter going to be if it's plus 50%?
Gonna be 150.
Well, it's going to be 15.
Oh, sorry.
It's increased by 50%. So here I have a diameter that's increased by 50%. Well, what's this radius over here?
5.
What's this radius?
7.5.
So the radius also increases by 50%.
Okay.
Now, what's the area again?
A equals pi r squared. Well, pi 1.5 r squared.
Okay, you got it. So A equals pi, and in parentheses, 1.5 r squared. And it's important to put that whole thing in parentheses because we do need to square the 1.5. So the area of the bigger circle is what?
The area would be 1.5 squared.
15 squared is a good one to memorize. It's 225.
All right. So pi 225 r squared, and then you divide it by 2.25. Sorry, 2.25 pi. And so, assuming yield is originally 1, it has increased by 225%.
Well, let's look at that. That's a little tricky. That's quite tricky.
Oh no, 125% because of the original 100%.
Right.
Yeah, we were learning about that in exponential.
That is definitely tricky. You got to be a little careful about that. If you increase 1 to 2, you're increasing it by 100%. If you increase 1 to 225, you are increasing it by 125%. It kind of depends on how it's worded. In other words, it's proper for me to say that that number is 225% of that number. Okay?
All right.
That's correct to say. But it increases by 125%. So they're not the same thing. To say that this number is 225% of that number means it's 2.25 times as big, and it is. But if I'm asking how much of an increase this is over that, then I need to subtract off 100% of that. Oh, well, you know what I mean. 225 minus 100. So we would get 125% is the percent increase.
Yeah.
Yeah, that's quite tricky. You just have to pay attention to the words being used. All right, we'll stop there. Pick up next week.
Oh. Okay.
You have a good one, and I'll talk to you next Tuesday.
Thank
All
you.
right, David. Bye-bye.
Bye.